everyone. This will be our first video of the year, section 2.1, the coordinate plane. If you'd like a set of blank notes that you can fill in as you go through this video, before you continue, find the blank notes folder in Polaris and you can print these out in advance and fill in the solutions to the questions as we go. If you don't prefer to do that or don't have a printer at home, you can always just take notes in your notebook as you normally would. Also notice on this first slide that our objectives will always be written at the beginning of a lesson. So if you're curious about what we will be learning about that day or what you'll be able to do at the end of the lesson, the objectives are a great place to find that information. Let's get started. To start this lesson, we're just going to review some terms for the coordinate plane. You can see a lot of this here is some stuff you did maybe in middle school or Algebra 1. Our quadrants are labeled. Quadrant 1 is in the top right corner, and then it goes counterclockwise. Quadrant 2, Quadrant 3, Quadrant 4. Our axes create a giant X or target in the middle, and right in the center of that we see our origin, or the point 0, 0. Our left-right axis is our x-axis, and our up-down axis is our y-axis. When we're plotting a point, any general point, you can see there's an example of 3, 4 given. You always begin at your origin and then go left or right first and up and down second. Okay, let's move on to our first problem. Our first problem here says the table below shows the rate per 1,000 population of live births and deaths from 1950 to 1985 at 5-year intervals. We need to plot the year and deaths in a Cartesian coordinate system, which is a fancy way of just saying our coordinate plane, and connect the dots with line segments. First of all, I want to point out that we have 3 columns in our table, and we're trying to make a scatter plot or a line graph. When you do that, you only need 2 pieces of information. So notice that we have, let me get my pen here, year and deaths that we were given that information. So that means this live births column is extra information. Maybe it would be used for another part of the problem if you were working on your homework. So year are going to be our x values and deaths are going to be our y values. One way to do this problem is to do it by hand, to make your scatter plot first and then connect the dots. But we're going to review how to do this with a graphing calculator because it can definitely save you some time in the long run. And this is a great tool to have at your disposal in the future. So if you have a graphing calculator, go ahead and get it loaded up. Hopefully the batteries are charged. And I'm just going to clear out what I have there, and I am on my home screen. The first thing that we need to do in the graphing calculator is enter this data. To enter the data, you're going to go to Stat. Then you're going to go to Edit, so hit Enter. And L1 and L2 should be seen there. If you don't have an L1 and an L2, I want you to do this very quickly. Hit Stat, select number 5, and hit Enter. And now when you go back into Stat Edit, you should see an L1 and L2 appear. If you have numbers in your L1 and L2, you're going to go up to the list name, hit Clear, and go back down, and that should clear the whole column for you. You can delete individual numbers, but you never want to delete the column name itself. Otherwise, that's when your L1 and your L2 disappear. So make sure L1 and L2 are cleared out. Again, go up to the list name, hit Clear, go back down, and now you're ready to enter your data. A lot of times when we do years, we don't put the first 2 digits in just because it makes our values smaller if we're going to calculate something. So we're just going to put in 50 for the first one, meaning technically we're graphing years since 1900, 50 years since 1900. And we'll get the rest of them in there. 55, 60, 65, 70, 75, 80, and 85. And now in my L2, I want to put my deaths. And notice I'm not changing the order on these. It's very important that you put them in as you see them in the table. 9.5, 9.4. You guys will probably be faster at home on an actual calculator than my digital one, so bear with me. And you want to make sure at the very end that you have the same number of values in your L1 column as in your L2 column. If there's an extra data piece in one or the other, you'll get an error when you try to graph it later. Okay, the next thing we're going to do is we're going to try to see this scatter plot. To turn on your plot, the easiest way is to hit y equals in the top left, and then go up to where it says plot 1 and hit enter, and your plot will be on. Another way to turn the stat plot on and to change the settings is to hit second y equals and select one of them. Again, let's say I want to do plot 1. I'll hit enter. You can see here's another place where I could turn it on or off. And then below it asks me a type. And here we did want a line graph. So we're going to go ahead and change it from a scatter plot to a line graph. Now you don't have to do this if you don't want to, but it will save you the time in connecting all the dots if you'd like. And then you can see there's some other options here, a histogram, a box and whisker plot, a frequency chart, some things maybe you used in previous courses. So we'll hit enter for a line graph. You can see that L1 and L2 we used a few minutes ago are our defaults, which is great. And then the last two, if you have a color calculator, you can change some options here. You know, the marking, instead of a dot, you'll see a plus, or you can change the color if you'd like. That's convenient if you're graphing maybe more than one scatter plot at a time. Okay, so we can just hit second, quit. That'll take us back to our home screen at any time. Now, if I want to see the actual graph, I'm going to go ahead and hit graph. And yours may or may not look like this. You'll notice right now that I do not have any data values showing up here. That's because, remember, my values were pretty large. I had all the way from 50 to 85 for my x's. My y's should show up there, but right now this is just a 10 by 10 window. I need to go a lot further to the right. The easiest way to zoom on data that you have is to go into the zoom menu. Zoom 6 is what we use a lot to get back to that standard window that you just saw a minute ago, the 10 by 10 window. But if we're graphing statistics, we want to use Zoom 9, Zoom Stats. So I'll just hit number 9, and then you can see I have a great picture, and I can just drag this over of our scatter plot. If you wanted to, then you could always sketch this or match it. If you're doing your homework, you can label the axes as well. Remember, we started with 50. So we'll put that there, and we ended up all the way at 85. If I was going to label this axis, I would say years since 1900 is what that x-axis represents. Oops, don't turn it. There we go. And I could do the same thing with my y-axis. My lowest value I graphed was 8.8. And you could always get a little more accurate with this with little hash marks and whatnot when you're graphing it at home. And my highest value I had was 9.6. And if I'm going to label this, this wasn't deaths in the year. If you look back at the original information, it said rate per 1,000 population. So it was deaths per 1,000 that we're graphing. And then this one I'll rotate here and just make it go sideways. Okay, and that's how you make a scatter plot or a line graph using your graphing calculator. Again, if you don't want to use the calculator for this part, you can always do it by hand as well. Couple quick reminders. If you want to get back to your normal window in your calculator, you're going to hit Zoom 6. If you want to turn on and off your plot, you can go into Y equals, go up, hit enter, go back down, and then you can see your plot is off. You want to make sure that plot is turned off if you do want to graph any lines or equations later on, because the calculator can give you an error message if the plot's on and you're graphing a line. Another quick reminder, second quit will take you back to your home screen, and second on will turn off your calculator. All right, let's move on to our next topic. So our next topic, one of the big formulas that shows up in this section, is the distance formula. Let me make this a little bit bigger for you. So the distance formula is actually just the Pythagorean theorem in disguise. If I have 2 points, let's call them point Q and point P. There they go. And I want to find the distance between them. One way to do this, if you don't remember the formula, is you can draw a right triangle. So figure out how far apart they are left and right, how far apart they are up and down. To figure out this length of my right triangle, here we go. you subtract the x-coordinates. To figure out this length for my right triangle, we subtract the y-coordinates, and that would be, think of it like your A and your B in the Pythagorean theorem. To calculate the hypotenuse, which is the distance between P and Q, we would need to do A squared plus B squared, and that would give us C squared. But in order to get C, we would have to get rid of that squared, so we take the square root of both sides. So square root of A squared plus B squared will give us C, which is the distance between our 2 points P and Q. Now, you'll notice if I take A and replace it with the difference between my x-coordinates, we see that show up here in the distance formula. If I take B and replace it with the difference between my y-coordinates, we see it show up there in our distance formula. So really, we've got underneath that square root an A squared plus a B squared, and then we take the square root to get ultimately C, the distance between our points. Notice your notation here, they're using a lowercase d to represent distance, and then P, comma, Q, which are the points that you need to find the distance between. So let's do a quick example here. I want to find the distance between the points -5, 2 and 3, -4. You can draw this out if you like, but I think it's always easier just to go ahead and use the formula. If you can, save yourself a little bit of time. So we're going to set up our big square root, and I'll put my parentheses here. So we're going to do x minus x. It actually doesn't matter which x you start with first. So let's say I just do 3 minus -5 squared plus, and then you just have to make sure whatever order you started with, which I started with my second coordinate first, you do the same thing in the second parentheses. So because I started with 3, I need to start with -4 in the next parentheses, minus 2. So I've got x minus x squared plus y minus y squared. Now I'm going to simplify each of my parentheses. In the first parentheses, 3 minus -5 gives me 8. And then if I square it, it gives me 64. Plus -4 minus 2 gives me a -6. If I square it, we know anything squared is always positive, gives me 36. Be careful putting that in your calculator. I see a lot of people every year that will put it in their calculator, but they forget the parentheses, and the calculator will tell you it's a -36 then. And then that obviously can make your answer wrong at the end. So just double check when you're doing these formulas that underneath that square root is always positive. Add together my two values, that gives me a 100. Take the square root of 100. Final answer is 10. If you want to label it, I wasn't given a unit here, so we'll just say units, and that's our final answer. An application of the distance formula is determining what kind of triangle, or you could just take this to what kind of general shape you have when you're talking about polygons. Here's a little review terminology for triangles. The first type of triangle that you learned in geometry was an isosceles triangle, and that's where 2 of the sides are equal length. The next is equilateral, that's when 3 sides are of equal length. And finally, scalene, which is when all 3 sides are different lengths, no sides are equal. To figure out if these 3 points determine any type of triangle, you need to find the length of the side of each part of the triangle, and to do that, because we're given coordinates, we're going to use our distance formula. So we're going to have 3 distances we need to calculate: the distance between D and E, the distance between E and F, and the distance between D and F. And these are in no particular order. You're going to have to do all 3 no matter what. Set up my big square root again. And right now I'm using the point D and the point E. All right, so I'm going to do my x minus my x, so -2 minus 6 squared. And then my y minus my y, 0 minus 2 squared. And if you're getting good with this, you could maybe do a bit of this in your head now. -2 minus 6 is -8 squared is 64. Plus -2 squared, that's 4. If I add 4 and 64, I get rad 68. We can break down that radical if we want to. Quick review on breaking down radicals. You want to find the largest perfect square that divides into that number. 4 is a perfect square that divides into that number, and 4 and 17 are the two products that make up 68. The square root of 4 simplifies to 2. Rad 17 is not a perfect square, so we leave it in the radical, and that's our exact answer. You do not want to give decimals for these answers. Make sure you're always giving exact values when you can. Okay, take a second on your own and see if you can find the distance between E and F and the distance between D and F. Okay, let me show you the quick work we're going to do for these. Between D and F, you should have 1 minus negative 2 and 5 minus 0, which is going to give me a 9 and a 25. Put those together, rad 34 does not simplify. Distance between D and F. Let me get a different color. There's my square root. Between D and F, I have 1 minus 6 squared, 5 minus 2 squared. I'm going to have a 25 and a 9 again when I simplify those parentheses squared, which gives me a rad 34, which does not simplify. So now going back to our original equation, we've done all the back work here. We need to figure out what kind of triangle we have. You'll notice that we have two sides, EF and DF, that are both square root 34. So that tells me that we have an isosceles triangle. Another application of the distance formula is to determine if points are collinear. Collinear is just a fancy way of saying that if you plot 3 or more points, they make a line. Of course, any 2 points make a line, but we want to know if 3 points make a line. The official formula is written here. Distance between A and B plus distance between B and C equals distance between A and C. That's a little confusing until you draw a picture of it. If I have 3 points that are collinear, and they don't necessarily have to be the same distance apart from each other, A, B, and C, it follows that the distance between A and B, the first segment, plus the distance between B and C, the second segment, equal the longest distance, the distance between the first and the last point, A and C. So the two smaller distances add to the larger distance is the big idea here. So looking now at our example, determine whether these following points are collinear. And you'll notice, just to save some time here, I gave us the same 3 points that we were dealing with earlier. So how you would start this problem is the same as the last one. You would find all 3 distances, so the distance between D and E, the distance between E and F, and the distance between D and F, which we already know the answers to. The first one was square root 68, which simplified to 2 rad 17, and the other two were rad 34 and rad 34. So the question to determine if they're collinear is, do the two smaller distances, rad 34 and rad 34, add together to get the larger distance, question mark, rad 68. Now your inkling here may be that this is a yes, rad 34 and rad 34 gives you rad 68, but the answer here is actually no, they are not equal. If you're not sure about that, you could always use decimals. This is a great way to compare numbers. This is a good like ACT strategy. Type in rad 34 plus rad 34 in your calculator, and this side of your equation would give you about 11.7. If you type in rad 68 in your calculator, you're going to get 8.2 approximately. So very obvious there that they're not equal. So we could say, no, they are not collinear. And logic should say, well, that would make sense anyway because we just determined in the last problem that they're isosceles. Now, if you're wondering, how do we add radicals, if you don't remember that from Algebra 2, if you're adding radicals, they must be the same radical, which the 34s are. rad 34 and rad 34 would add together to simplify to be 2 rad 34 would be the exact answer, not rad 68. Here we're going to use the distance formula to find a missing part of a coordinate. Here we want to find x so that the point x7 is 5 units from the point 5, 4. 5 units is a distance, and that's our clue that we're going to be using the distance formula. So I'm just going to set up a distance formula here. Here's my big square root. On the left, we're going to put our distance, which here we're not finding, we know it's 5. And on the right, we're going to fill in our parentheses with our coordinates. So x minus x, 5 minus x squared, y minus y, 4 minus 7 squared. Let's simplify this. Square root of, now this first parentheses, 5 minus x, those are two terms in a parentheses squared. Because I don't know the x, the only thing we can do to simplify this is FOIL. Remember, 5 minus x squared means 5 minus x times itself. If you need to write that out, 5 minus x, 5 minus x, and then do your 4 foiling steps, F-O-I-L, first, outside, inside, last. Go ahead and do that. I'm just going to do this very quickly. I'm hoping everybody's pretty good at foiling at this point. So my first terms would be 5 and 5. That's 25. My outside terms would be 5 and negative x, so negative 5x. My inside terms, also negative 5x, so put those together, I'll have a negative 10x. And my last terms, negative x and negative x, would give me a positive x squared. Now the second parenthesis is a little bit easier because I know both of those numbers. 4 minus 7 gives me negative 3. Square it, positive 9. Next thing I can do is I can simplify a little bit under that square root. I have a 25 and a 9, which is going to give me a 36. And I like to reorder these when I can. I always like to put my highest exponent first. You may have remember doing this a lot when you factored in Algebra 2. And then I'm also in this step, or you can do this in a separate step if you like, going to choose to square both sides right now to get rid of that square root. 5 squared is going to give me 25. Now to solve this equation, because I have a quadratic, our next step is to get it equal to 0. So I'm going to subtract 25 over to the other side, which is going to give me a, let's see, 11. Oh, hold on a second. I think I made a mistake there. Let's go back. Sorry guys, I can't add 25 and 9. Whew, terrible. How about a 34? That's a little bit better. And if I subtract 25 from that, I'm going to get 9. That's a little better. Okay, to solve this at this point, you can either factor or you could use the quadratic formula if you like that. Factoring is definitely going to be a little bit faster here because we don't have any coefficient in front of our x squared term. You just need to find two numbers that multiply to your last term and add to the middle term, variable in the front of each parentheses. Two numbers that multiply to a positive 9 and add to a negative 10 are negative 1 and negative 9 in no particular order. You could always switch those. Once you are factored, you set each factor equal to 0. This is called the zero product property. Again, review from Algebra 2. And you solve x equals 1 and x equals 9. Now, why are we getting two answers here? That's because there are 2 points that are 5 units away from the point 5, 4. One to the left, 5 units, and one to the right, 5 units, which is why you're seeing two different solutions. Our answer here said, or our problem here said to find x. We did find x, 1 and 9. Be careful when you're doing your homework. It may ask you for the full point, so you may have to type in 1, 7, and 9, 7 as a solution. MathXL will be a little tricky at first, just getting to see kind of the nuances of it. Make sure they're always very specific about the instructions. It'll tell you to round to a certain decimal place, or don't round to the end, or fill out a coordinate, or give an exact answer. All those things will be helpful as you're working through it. Here's another example of when we could use the distance formula. This problem says find a point on the y-axis that is equidistant, which means equal distance, from the point -3, 0 and the point 4, 7. equidistant is the biggest clue in this problem, that you're going to have two distances set equal to one another. We are finding a point on the y-axis. If you think about anything that's on the y-axis, any general point, you could always plot one as an example if you'd like. Those coordinates always have an x value of 0, and the y is what changes. So 0, 1, 0, 5, 0, 7. So I'm just going to use the general point 0, y when I do this. Okay, so I need my point that I'm finding to be the same distance from negative 3, 0 as it is from 4, 7. So we're going to pair up 0 with y and 3, 0 to calculate our first distance. And then we're going to pair up 0y and 4, 7 together for our second distance. So let's fill in our distance formulas. The first one is x minus x, so negative 3 minus 0 squared, and y minus y, so 0 minus y squared. Now I'm going to pair up 0y with 4, 7. X minus x, 4 minus 0 squared, and y minus y, which is 7 minus y squared. I'm going to say right now, let's just square both sides of the equation, because both sides are under a square root. My square roots will just disappear. Now let's simplify underneath these square roots. On the left, negative 3 minus 0 is negative 3 squared, gives me a positive 9. And then 0 minus y is just negative y. Negative y squared, or negative y times negative y, is a positive y squared. On the other side, 4 minus 0 is 4 squared, gives me 16. And then here again, I can't simplify 7 minus y, which means my only choice is to FOIL it. First term, 7 and 7, which give me 49. Outside and inside terms would both be a negative 7y, which give me a negative 14y. And my last terms, negative y and negative y, give me a positive y squared. Now I'm going to simplify both sides here. The left, I can't do anything with that. On the right, I'm going to reorder my terms a little bit. Y squared, negative 14y, and then if I pair up the 16 and the 49, I'm going to get a 65. You can see again I have a quadratic, so I want to get everything over to one side. Let's say, just like the last problem, we decide to move it over to the right. If I subtract y squared on each side, you'll notice actually here they both just cancel out. So I don't even have a quadratic anymore, which is great. It's going to be a lot easier to solve. We just have a linear equation, which means my highest exponent is a power of 1 on that y. If I want to solve for y, I isolate my y term. If I subtract 65 from the other side, it gives me negative 56 equals negative 14y. And then divide by negative 14 on each side. I'm going to get y is a positive 4. Now back up to my original problem. My problem said find a point. So if you just typed 4 into your solution in MathXL, it would mark it wrong. The answer is a point, a coordinate, and we already decided earlier that if it's on the y-axis, the x-coordinate is 0, and the y-coordinate is what we just calculated. 0, 4 is the point that we're looking for. If you want to check that, you could plug 4 back in at the top where you had your distance formulas and make sure you have the same value on each side. Another great way to check this is you could just make a quick sketch on some graph paper and make sure that that point makes sense based on the original coordinates you were given. Last problem in this section is a quick one, the midpoint formula, just a little bit of review. The midpoint formula is almost like an averaging formula. It's the average of the x coordinates and the average of the y coordinates for any 2 points that you're given. So we'll just run through this one quick. Find the midpoint of the line segment whose ends are at 5, negative 2, and 6, negative 1. To use that formula, we're going to add up our x coordinates, 5 and 6, divide it by 2, essentially finding the average. Add up my y coordinates, and divide by 2. 5 and 6 give me 11 over 2. Negative 2 and negative 1 give me negative 3 over 2. In this class, we definitely prefer to use fractions rather than decimals if possible, especially if you have an answer that is not exact as a decimal. For example, 1/3 is 0.3 repeating. You would have to put the bar over it. If you round it, it's going to be marked wrong, so definitely the fraction is preferred. Problems like this, though, where you can get an exact decimal that you do not have to round, that would be acceptable to give as an answer. So here this would be 5.5 and negative 1.5. Again, MathXL will be specific, though. In the fine print, it'll say write your answer as a fraction or write your answer as a decimal. And if you don't put your answer in the proper form, it will mark it wrong. So just make sure you're aware of that. Okay, that's the end of our first lesson, section 2.1. If you're an e-learner, you can go ahead and get started on that section right now if you'd like for MathXL. Or if you're an in-class student, you can also do that. In-class will be used for working on this homework. On Monday will be the first day that we have our Google Meet session. Remember, those will begin the first 10 to 15 minutes of each class period. You can log in, ask questions in the chat if you'd like. We'll just kind of review this lesson if there's anything we need to discuss, and then the rest of the class period will be used to work on this assignment. And then on Monday, again, your homework will be the next video lesson. If you have any questions on the MathXL, make sure that you're hitting that email my instructor. That's the best way that I know what you guys are struggling with or what you need help with, or even what I plan to talk about during those Google Meet sessions. If you're an e-learner, feel free to go into those Google Meet sessions at any time of the day. If you're an in-person learner, if you maybe have a study hall or another time of the day where you're free and you want to pop into a Google Meet just to ask a question, feel free to do that. Thanks for watching, guys. Have a nice weekend.